Bismillahirrahmanirrahim. Last time we discussed the lateral surface of the parietal lobe. We talked about the sensory cortex area number 3, 1 and 2. Over the post-central gyrus. Now rest of the lateral surface of the parietal lobe was left, and I told you after finishing with the auditory area and the visual area, we will again discuss the remaining parts of the parietal lobe regarding broadband cortical areas. Now you know the lateral surface of the parietal lobe is traversed by intraparietal sulcus, dividing into superior parietal lobule and inferior parietal lobule. The superior inferior parietal lobule, this whole area, is numbered by Broadman with area number 39 and 40. Then I told you the posterior members of the lateral sulcus turn upwards and run in the lower part of inferior parietal lobule. Similarly, the posterior end of the superior temporal sulcus also run upwards into the lower part of the inferior parietal lobule, and the posterior part of the inferior temporal sulcus also run upwards and end in the lower part of the inferior parietal lobule of the parietal lobe. Now the gyrus which surrounds the upturned end of the posterior members of the lateral sulcus is known as supramarginal gyrus. The gyrus which surround the upturned end of the superior temporal sulcus in the lower part of the inferior parietal lobule is known as the angular gyrus, and the gyrus which surround the upturned end of the inferior temporal sulcus, this is known as the posterior parietal gyrus. Now the supramarginal gyrus is numbered by government is area number 40, and the angular gyrus area number 90. Government cortical area number 90. Now the superior parietal lobule and upper part of the inferior parietal lobule numbered as area number 39 and 40, same as here, supramarginal gyrus number 40 and angular gyrus 39. So superior parietal lobule, inferior parietal lobule is known as parietal area. Area number 39 and area number 40. This is, as I told you, is one of the larger association areas. Of cerebral cortex. Now this area is very important, area 39 and 40. Why? Because it is in between some very important areas. For example, in front is the sensory cortex, broadband cortical area number 3, 1, 2, and the lateral surface of the post-central gyrus. Behind it, can you see the visual center? Area number 17, area number 18, area number 19. The visual area, striate, parastriate, and peristriate areas. Located behind it and close to it. Below and in front is the auditory area. Area number 41 and 42. In the upper part of the superior temporal gyrus and anterior transverse gyrus. So it is also below and in front of the parietal area. And then again in front of it, apart from motor area number 4, is the Broca's area. Area number 44 45. And you know Broca's area is motor speech area. Motor speech area. So, area 39, 40, superior and inferior parietal lobule lateral study is very important because of its relation with the sensory cortex, with the visual cortex, with the auditory cortex, and with the motor speech area, Broca's area. Now, what is the functional significance of this thing? Now, for example, I ask you that what is this? So first of all, using your sensory cortex, area number 3, coordinate cortical, you will feel it, and you will come to know some information, sensory information about this object. It is hard or soft, what is its temperature, what is its shape. So all this is sensory information about this object is received by area number 3 and area number 1 and 2 further interpret. Then visual sense, you can see it using your visual center, what is the shape, what is this size, whether it is fixed or it is moving, whether it is opaque or transparent, it is translucent, it is illuminating or not. All this visual information reaches area 17 and then further interpreted by area 18 and 19. Then I will tell you that this is marker. And you will hear this by area number 41, 42, auditory area, interpreted by area number 22 in the temporal lobe. You see the Broca's area is in the frontal lobe, auditory area is the temporal lobe, visual area is the occipital lobe, and this area is in the parietal lobe. So, you know the sensory information, the visual information, and auditory information about this object or some subject. After a while, again I will ask you what is this? You cannot describe. So what you will do? You will first again feed it and collect sensory information by area number 3 about this object. Then you will see it and you will get the visual information about this object in the area 17, 18 and 19. Then I will again tell you it is a marker. And after a day or two, for example, again I will ask you. You will not know. Again you will feel it using your sensory cortex. You will see it by your visual cortex and by your hearing pathway and hearing center. Somebody will tell you it is marker. Now all this sensory information, visual information, auditory information about this object or subject is received and retained. The sensory information, the visual information, and auditory information. Is received and retained by areas number 39 and 40. That is parietal area. Parietal cortex. All the sensory information, visual information, auditory information is received by parietal area 39 and 40. Not only it receives but retain it. Now, the question arises for how much time you will obtain the information about this object. It depends upon the interest about your interest about that subject or object. Suppose a person meets you, discuss some issue with you, he will tell you that my name is Anwar. For the first time he met you, he then explained the reason for the meeting. After some time again he asks you, what was your name? So you will not able to retain, you will not retain his name in his name. It depends upon your interest with that object or something. So for how much period it is retained. I will give you an example. For example, you are medical students and you have different friends and class fellows. And one of your class fellow is all the time very regular attending classes. After classes, you will find him in the laboratory. And after laboratory, instead of going to the tea bar, canteen, he will go to the library. And he will have a bag having so many books. So all the time he is running between the lecturer, laboratory and library. And when he appears in the exam, sometimes he passes in the annual exam, sometimes in the supply exam, even so much interested in study. So when you will do MBBS and then when you will do post-graduation, after so many years, you invite some of your class fellows, the doctors, and then you talk about the past, your college life. You will remember that fellow, that your class fellow, who has these features. So the information about that person is retained for so many years in the area 39 and 40. So memory is stored here. There is another part of the brain which is mainly for memory, that is the limbic lobe that we will discuss later on. But what is the role of 39 and 40? Again, it plays an important role in the memory. So all the information about subject and object is received and then retained. Received from visual information, sensory information, auditory information in the area number 39 and 40. And it is retained there for some time period or throughout your life. This is the importance of this area. Second, this is the object, and you know the sensory information, visual information, and auditory information about this object. Clear? So, you ask your friend to close his eyes, and then you put this object in his hand, in the fist, and you will ask him to do not open the eyes and tell me what is this. Immediately he will say, these are glasses. Or you put a key in his hand with closed eyes. You ask him to close eyes and you put a key in his hand. And you will ask, what is that? Immediately he will recognize that object, that it is key, without the vision. So, recognition of an object without the aid of vision. Of an object or subject, maybe human body, maybe animal, maybe an object. Recognition of an object or subject without the aid of vision. Without seeing it, known as stereognosis. recognition of an object without the aid of vision, this function is called stereognosis. It is also the function of area number 39 and 40. Now, if there is a lesion of this area, and you ask your friend or somebody that what is this? He is feeling it, he is seeing it, and he knows, he will say these are glasses. Then you ask him to close his eyes. After closing the eyes, you place that object in his hand. And then when there is lesion of this area, and you ask what is this, he will be unable to recognize. Without the vision, he cannot recognize. But if you ask him to open eyes and see, then immediately he will recognize. So this failure to recognize an object without the vision is known as stereognosis. If there is lesion of this area, it will result in stereognosis. The function is called stereognosis, and loss of this function is known as stereognosis. So this is also the important function of the area number 39 and 40, that even if without vision, without seeing the object, you can recognize an object using your past experience. This is also an important function of this thing. Next, we will discuss speech. Now, speech has two types of modalities. What is speech? What is the speech? What are its modalities? There is motor speech, motor component of speech. And sensory component and modality of speech. Therefore, we have two types of centers: the motor center and sensory speech center. Motor speech center and sensory speech center. The center for motor component of speech is Broca's area. Broca's area of cerebral cortex, area number 44-45. Broca's area. The pars opercularis and pars triangularis, area number 44-45, on the lateral surface of the lower part of the frontal lobe. This is motor speech area. That is, you use musculature to give shape to the voice in the form of words and sentences. Using muscles of the larynx, I mean to say muscles of the vocal cords, pharynx, muscles of the lips, tongue movements, palate movements, all these movements are because of muscle contraction, and in this way it gives a shape to the word. This is motor area. And what is sensory component of the speech? That is ability to understand what is sensory speech. Ability to understand the spoken word or written word is the sensory component of the speech. The sensory component of the speech. And what is this? It's wernicke area. What is that area that I will explain later? Wernicke area, especially the angular gyrus. Angular gyrus, area number 39. And the Broca's area, you know, area number 44, 45. The pars triangularis and pars ocularis. So, this is what about the speech types and their sentence and the definition. The sensory speech is that ability to understand the spoken word or written word. I have given this example before also. So if I say Pakistan and ask you, you will also say Pakistan. I write on the board and I will ask, read it out. The person who is normal sensi, he will read it out, Pakistan. But if there is a relation of the sensory speech area, when I will ask the patient to say Pakistan, although he is listening, but he is unable to understand it. He will not repeat Pakistan. Then I will write the word Pakistan and I will ask him to read it out. He will be unable to read it out, although he can see. So in this way, when the this sensory area is affected. So therefore, if there is loss of motor part, that is Broca's area delay, it will result in motor aphasia. And when the sensory center is damaged, it will result in sensory aphasia. Now, Broca's area, already we discussed it, is on the lower part of the lateral subfield frontal lobe, pars ocularis, broadband cortical area of 44, and pars triangularis, broadband cortical area of 45, separated by these rami of the lateral surface. Now, next is the wernicke's area. Broca's area. Pars opercularis and pars triangularis. area number 44 and 45. Firstly, it is motor speech area. Next is wernicke's area. Wernicke's area. Parietal temporal area. Parietal temporal area. Parietal temporal cortex. Wernicke's area. Parietal temporal. Why? You can see this is lower part of the inferior parietal lobule and posterior part of the temporal. Posterior part of the temporal area. For example, this area. The area in the neighborhood of inferior parietal lobule. This is parietal temporal cortex, wernicke's area. It includes which ones? It includes supramarginal gyrus. Area number 40. Then it includes angular gyrus. Area number 39. And posterior parietal lobule. Posterior parietal gyrus. Now you can see in this diagram supramarginal gyrus in the lower part of the inferior parietal lobule. It is area number 40. Same area 13 and 40 extend to here. Then the supramarginal gyrus, this one, the angular gyrus. Angular gyrus. It is area number 39 in posterior parietal lobule. This one, posterior parietal lobule. Now, this is wernicke's area. It includes the lower part of the inferior parietal lobule and adjoining part of the posterior portion of the temporal lobe. Here is artery central area 41, 42. The rest of the superior temporal gyrus is area number 22. Then middle and inferior temporal gyri are also there. It is structurally functionally same as area number 22. And their posterior part of the superior middle inferior temporal gyri, it is included in this wernicke's area, which is in the parietal temporal part of the cerebral cortex. Now I told you it is mainly this angular gyrus. It is sensory speech area. angular curve. In many books, they say mainly it is this angular curve. Although Wernicke's area include area number 40 supraparietal caries, posterior parietal caries, apart from angular caries. But it said in many books that it is this angular area which acts as a sensory speech area number 39. This one, angular caries. So these were the two areas, one Broca's area or the motor speech area and the Wernicke's area. It is sensory speech area. Part of it mainly the angular caries for sensory speech. Now, what are the connections of Wernicke's area? Connections area. What is the speech circuit? This is the next topic. This area have connections. Now to speak, you have to feel. You have to see and you have to hear. Of course, you close your eyes, you can speak. But during speak, you use various areas, various modalities. You have to feel, you have to see, and you have to hear. And there is a center for sensation, there is cortical sensation for vision, there is a cortical center for hearing. For feeling sensation, you have sensory cortex. That is Broadman cortical area number 3 mainly, and 1 and 2. They interpret further detail. And one has to see visual center, visual cortex. Visual cortex, that is area number, Broadman cortical area number 17, 18, 19. Mainly 17. Information reaches here, then it is further interpreted by area 18 and 19 in the occipital lobe. Then for hearing, auditory cortex. In the temporal lobe, you know area number 41. Area number 42. For hearing. So, during speech, you feel by sensory cortex, especially Broadman cortical area number 3. Post-ungular. For seeing, you use area number 17, interpreted by area 18 and 19, in the occipital lobe. For hearing, auditory area 41, 42, transverse temporal gyrus and organic part of the lateral surface of the superior temporal gyrus, and it's detailed about area number 22, association area. Therefore, the fibers from these areas, sensory area, visual area, auditory area, should be projected to the wernicke. So, fibers from sensory cortex, the sensory cortex is connected to the wernicke by a bundle of nerve fibers. Then visual information from nearby visual center. The fibers from the area number 17, striate cortex, project into the wernicke area. Then auditory center, fibers from the auditory center also project to the wernicke area for hearing. So it is very simple. If you know the close relations of this wernicke area with the other important center, so you can easily understand and remember that the nerve fibers from which areas enter the wernicke area. That is sensory cortex, area number 3, visual cortex, mainly area number 17, and auditory cortex, mainly area 41, 42. They reach the wernicke area. Now, this is sensory speech. Now is the motor speech. For motor speech, we use area number 44, 45, broadman cortical area. Therefore, now the wernicke area is connected to the Broca's area. By a bundle of nerve fibers. These are incoming fibers from sensory cortex, from visual cortex, and from auditory cortex. Now, outgoing fibers in the form of bundle of nerve fibers, they arise from the wernicke area and reaches the Broca's area. These bundle of fibers which connect the wernicke area with the Broca's area is known as arcuate eminent. Special name is arcuate fasciculus. The bundle of arched bundle of fibers known as a tract of fasciculus. So, arcuate fasciculus. Fasciculus is the other name for a tract. So those bundle of fibers which connect the wernicke area with the motor speech area is known as the arcuate fasciculus. So, from the sensory speech area, receiving fibers from the nearby sensory cortex, auditory cortex, visual cortex, then it is connected by a bundle of nerve fiber tract called arcuate fasciculus with the motor speech area, area 44, 45. Now, I told you that to give shape to the words, musculature of the larynx, pharynx, lips, tongue, jaws, etc. is used. Therefore, ultimately, what happens that the Broca's area is connected with motor cortex. To give shape to the words by motor activity, by movement of the tongue, palate, vocal cords of the larynx, lips, jaws, etc. Broca's area is then connected to the broad cortical area number 4, which innervates the voluntary, and control the voluntary movements of the opposite half of the body. So in this way, one is then able to speak. These were connections of speech, very simple. If you draw this diagram again and again, label it, and if you know the close relation of this wernicke's area with the sensory cortex, visual cortex, auditory cortex, then motor area, Broca's area, and then area number 4. This is the speech circuit, or the connections of the wernicke's area. Which fibers it received and which fiber connected it with the Broca's area, and Broca and this area then connected to the area number 4. So all these were language, and speech. Centers. On one hand is the motor speech area, Broca's area. On the other hand is the wernicke's area, sensory speech. These are the centers for language and speech. Now the question arises, what is the difference between language and speech? What is the difference between how we differentiate, how we define these two components? And what is language? And what is speech? What is language? Language is the use of voice. In other words, sound. Language is the use of voice or sound to express or and communicate. To express and communicate with group. To express and communicate with the groups of people. With groups of people who understand that language. Who understand that language. This is how we define the language. And what is speech? What is meant by speech? Speech is the ability Speech is the ability to speak in a language. This is how we define the speech. So what is language and what is speech? Suppose there is a group of people who can speak in Urdu. So you will communicate with him in Urdu, not in English. Then there is a group of students who do not, a group of people who do not understand any other language, only English. Then you have to speak in English with that group of. If there is a group of people who speak only in Pashto or Balochi, you will speak in Pashto or Balochi with them. This is the language. And the speech is the ability to speak in that particular language. One has to have ability to speak in Urdu, English, and other languages. That's not a speech. So this is how we define and differentiate what is meant by language and what is meant by speech. So all these, the Broca's area, wernicke's area, these are, if you ask what are the symptoms for language and speech, you will describe Broca's area and wernicke's area. On the supralateral surface of the cerebrum, particularly the lower part of the parietal lobe and the posterior part of the temporal lobe. So this was about the parietal lobe, cortical areas 39 and 40, and along with it the parieto-temporal cortex, which is wernicke's area, which comprises of different gyri. Number is area 39 or 40, and of this mainly in many books, it is the angular area 39, which is considered as the sensory speech area, and Broca's area is the motor speech area. Thank you very much.